Okay, today we are moving on into the second half of chapter 2, and we're going to continue with polynomial functions through this second half as well and do different things with them. But today in 2.5 here, we are going to be looking at the rational zero test, also known as the fundamental theorem of algebra. We've talked about this in Algebra 2 and different things, but basically the fundamental theorem of algebra tells us how many solutions a polynomial has. It tells us how many. It doesn't tell us what they are, it just tells us how many when we're all done solving this polynomial, finding all of our solutions, how many we should have. And all we have to do to find that is we just look at the highest exponent. The highest degree, or the highest exponent, tells us how many, but it doesn't tell us what they are. So in order to know what the possible zeros are, okay, this list we're going to make right here doesn't tell us, again, it doesn't tell us what the solutions are, but it'll tell us what the possible solutions are. And it's called the PQ list. If you notice, that's because it says P and Q, okay? So to make a list of the possible zeros, like this is going to be the list of possible places where this graph could cross the x-axis or bounce at the x-axis or wiggle at the x-axis, we make a list and it's plus or minus, okay? And on the top in our numerator is going to be, on the top in our numerator is going to be P. And P, it's going to be plus or minus, okay? It's going to represent the factors of the constant. Okay, remember the constant is just the number that is not attached to any variable. It's just the number hanging out there all by itself. And then in the bottom, Q represents the factors of the lead coefficient. So that's going to be the factors. We're going to call that of LC, because that's what we called it when we did the bounce wiggle cross, is the lead coefficient. And when we do that list, it's going to tell us, here's a list of possible places that we could have as answers. Okay, and then we will use this list, and then we're also going to use our calculator to find some of the zeros, and then we're going to have to do a little synthetic division to get down towards the end where we can actually find all of the solutions. Okay, so here we have a function, x to the fourth minus x to the third plus x squared minus 3x minus 6. Okay, how many zeros does this polynomial have? Well, we've got the highest exponent is a 4. Which means there are 4 answers that we're looking for, okay? So we're going to list the possibilities, okay? P, again, is the factors of the lead coefficient, or excuse me, the factors of the constant, excuse me. In this case, the constant is 6, or negative 6, okay? And then our lead coefficient, that number out in front, is just 1. So if we were going to list in the numerator, the factors, these are the factor pairs, things that multiply together to be 6 or negative 6. We would have 1 times 6 and 2 times 3. That would be all of our factors of 6, and then the only factors of 1 are just 1. So our possible solutions that we could find on our graph, doesn't mean that they're all going to be answers, is we could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And in order to know which ones actually are the solutions, and this list up here also allows us to say, okay, I got this as an answer. Is that a possible solution? Is that actually legit type of thing? Okay. So we're going to use our graphing calculator to determine the integer solutions. Remember, integers are just positive and negative whole numbers. So that basically means integers are going to be no fractions, no decimals, anything like that. Decimals, no decimals, oh my gosh, no decimals. That's supposed to be the word decimals, okay. No decimals. We're just going to look at our graphing calculators to help us find those real solutions, okay? And then we're going to use synthetic division and factoring to find the list of all the roots, including any that might be imaginary, okay? So let's go ahead and use the graphing calculator. So on your graphing calculator, you're going to go into the y equals, and you are going to put in that equation up at the top, x to the fourth minus x to the third minus 3x minus 6. You're going to put that in the graphing calculator, and then you're going to hit graph. And what you are looking for is the nice places where it crosses the x-axis, okay? So if you want to pause the video for a second, get yourself into your graphing calculator so you can see what you're looking at. You are also looking for the value of x when y equals 0. So you can also use your table if you would like to do that, where you can look and see what the value of x is when y equals 0. Otherwise, you can just look at the graph and see where it crosses, bounces, or wiggles. And in this case, when you look, the places that you notice that it crosses are at x equals -1 and at x equals 2. So we know that those two are going to be solutions, which means they should divide evenly into our original equation. So we are going to go ahead and synthetically divide by those two. Okay, so we're going to put that -1 on the outside. We're going to build our house. We're going to put our coefficients up in the top here. 1, -1, 1, -3, -6. And the more you do this, the more often you do this with synthetic division, the better you become at it. So we are going to drop that all the way down into the basement. -1, add, we get -2, multiply, we get +2, add, we get 3, multiply, add, multiply, and add. And if you did it correctly, then you should have a 0 for a remainder. Remember that we started with up here we started with a 4th power, which means this is going to be a 3rd power that we have here, okay? And then we need to use our second 0 that we know, which is at x equals 2. So we're going to go ahead and we're going to put 2 on the outside. And we're just going to synthetically divide again, drop that first number all the way down, multiply and add, multiply and add, multiply and add. And what we have here is going to be our second power. That's going to be our quadratic that we are able to actually solve. So that means that we'd have a second power as our highest power. So we are going to have 1x to the second power plus 0x plus 0x. I'll go ahead and write that down, plus 3. And in order to find these imaginary solutions, we're going to set that equal to 0. So we're going to have x squared plus 3 equals 0. We didn't have to put that 0x in there, but that's just so we know we have place fillers in here. So then I'm going to subtract 3 from both sides, and I get x squared equals -3. When I take the square root of both sides, we are not going to forget to put the plus or minus in the front. And we have to take that square root of -1, which is I, out, and then the square root of 3 has to stay where it's at. So we're going to have the I on the outside and the square root of 3 on the inside. So if we were going to list all of our solutions, we would have x equals -1, 2, and positive or negative I times the square root of 3. That would be our 1, 2, 3, 4 solutions, which we said in the very beginning is what we were looking for. There are 4 solutions because the fundamental theorem of algebra, highest exponent is 4. Okay, so let's just look at another example here. Let's just do the same thing. And this time, we're going to go a little bit quicker. Okay, so we are going to have, we know there's going to be 3 solutions because my highest exponent is 3. Let's make a list of all the possibilities. So we're going to have plus or minus, and the numerator is going to be the factors of 10. And then the denominator is going to be the factors of 3. So the only factors of 10 are 1 times 10 and 2 times 5. 5. And then in the denominator, the only factors of 3 are 1 times 3, which means you could have 1 over 1, or just anything over 1, 1, positive 1, negative 1, positive 2, negative 2, positive 5, negative 5, positive 10, negative 10, positive 1/3, negative 1/3, positive 2/3, negative 2/3, positive 5/3, negative 5/3, positive 10/3, negative 10/3. So the reason we like to use our graphing calculator here is that otherwise we'd have to do trial and error to decide which of all of those possibilities actually are solutions. So we are just going to use our graphing calculator to determine the integer solutions. Again, we're going to put it into that y equals, and then we're going to hit graph. And we are looking again at the interaction it's having at the x-axis, wherever it's bouncing, wiggling, or crossing. And then that's going to be our solutions that are integer solutions, and then we have to use those to find the rest of them. Okay, so as you look, Again, if you want to use that table, you can look at the table and see that value of x when y equals 0. Or you can just look at where it crosses. If there are any places where it crosses in between, we are only looking for integers, whole numbers, nothing in between with fractions or decimals. So it looks like, as I look here, I've got x equals -5 and x equals 1. So there's 2 of our 3 solutions that the graph gave us already. So we're going to go ahead and we're just going to synthetically divide with those. Doesn't matter which one you synthetically divide with first. I'm going to go with -5, and I'm going to put my coefficients in there. 3, 14, -7, -10. And again, if you do this correctly, you should have a 0 as your remainder. So we're going to drop that down. We're going to add, or excuse me, we're going to multiply around and add, multiply around and add, multiply around and add. Good. So that original one was a third power, which means this would be a quadratic. This would be a second power here. Okay. And then we're going to go ahead and divide by that second factor it told us, which is 1. And we're going to drop down that 3, multiply around, we get 3, add, we get 2, multiply around, and we get a remainder of 0 again. Now this is going to be a first power, which means our highest exponent is going to be x to the first. So we would have 3x plus 2 equals 0. So we would subtract 2 from both sides and divide by 3, and we get -2/3. So if you remember looking at your graph, and there was an actual place that it crossed between 0 and -1, that's because there was a fraction answer that we could use the synthetic division to find. Okay, so in the end, our 3 solutions that we said we should have was -5, -2/3, and +1. Okay, the last one here that we're going to do, okay, is going to be probably the hardest one. It's going to require some quadratic formula and things like that with imaginary solutions potentially. So let's look. All right, highest exponent is a 4. Okay, our possibilities here, we have plus or minus. Again, the factors of 42 go on the top, which is going to be 1. I like to list them in pairs on the ends, like 1 times 42, 2 times 21, 3 times 14, 6 times 7. Okay, and then in the bottom is the factors of our lead coefficient, which is just 1. So again, all the possible solutions we could have would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so on. And we do not want to have to test all of those. We use our graphing calculator to find which of those integer solutions we would have. And as you look, there are 2 of them. It crosses nicely at x equals -3 and at x equals -2. So we're going to take, and we are going to just synthetically divide twice. So we're going to take that -3 here on the outside and synthetically divide. So I'm going to have 1, 8, 14, -17, -42. And again, it does not matter which one you synthetically divided by first. Drop it down, multiply and add, multiply and add, multiply and add, multiply and add. And again, that 0 remainder is what we're looking for. And again, we started with a 4th power, which means this would be a cubic or a 3rd power. Okay, we don't know how to factor cubics just yet. So then we're going to do our other one, which is -2. And we are going to bring it down, multiply and add, multiply and add, multiply and add. Okay, so this is going to be our 2nd power, right? This is going to be our quadratic that we can solve. So we are going to have 1x squared plus 3x minus 7. Okay, just a quick thought bubble over here. Okay, if we are going to do our what times what and what plus what, they would have to multiply together to be -7, and they would have to add together to be +3. Well, I don't know about you, but I do not know any factors of 7 that add together to be 3. So we actually cannot even use the box method on this one. We are going to have to use the quadratic formula, which is good because that's good practice for us to remember how to use the quadratic formula. Okay, so the quadratic formula, just a reminder, is the opposite of b plus or minus big ol' square root of b squared minus 4ac all over 2a. And a reminder that in this case we have a equals 1, b equals 3, and c equals -7. So the opposite of b is going to be -3 plus or minus the square root b squared. Well, b is 3, so b squared is 9, minus 4 times 1 times -7, all over 2a, 2 times 1, which leaves us with -3 plus or minus the square root of 9 plus 28, which is 37, all over 2a. 2a is just going to be 2. So all of our solutions, that's what we would get if we had, let me erase that for a second. I'll come back to that in a second here. So we said that we should have 4 solutions. Well, our 4 solutions are going to be x equals -3. That was from the graph. -2, that's from the graph. And then the opposite of 3 plus or minus the square root of 37 over 2. So there's 1, 2, 3, 4, because that plus or minus means that there's 2 solutions. And in this case, there was no imaginary solutions. So if you look at your graph, you might notice there are places where it's crossing the x-axis, but it's in between 2 numbers. The only integer solutions were at -3 and -2. So you're basically going to have to decide, on this last step here, if you can factor it using, the AC method where they multiply together and add together, or if you can just use the quadratic formula. I will tell you the quadratic formula, if you are familiar and are good at it, will work every time. If you can't decide how you want to solve the quadratic, you can always use the quadratic formula. So good luck, and I will talk to you later.